Hello and good morning, CTS267 Section 840 students for the Spring 2017 semester at Anne Arundel Community College. This is the CCNP TSHOOT course, and this morning's video tutorial is going to be a tutorial and solution set on challenge activity number 8, where we're taking our first look at the PILE Forensic Accounting Ltd network, and they've got some issues that we're going to need to troubleshoot. As you can see, we've got a different network layout than we have in the previous troubleshooting sections. So let's dive in here and take a look at the scenario. So we are still a Sechnik Networking Limited employee. Looks like Peter, one of our colleagues, did some improvements on the customer network over the weekend. On Monday, Carrie had some issues. So she received a call from the branch office and that it was cut away from headquarters. And so here is our branch contingent out here. You can see we've got this WAN link here. So if you're making assumptions, right, whether they're good or bad, you may be thinking, okay, maybe it's a encapsulation issue. Maybe one side's PPP, the other side is HDLC. Maybe we've got a networking protocol that's running over that link that maybe one side is broadcast and the other side is point-to-point. Any kind of errors like that, right? So could have some issues right here between HQ2 and the branch. So we've got to get that sorted out. And then Carrie noticed that if ISP1 fails over here, so our connection out this interface, that ISP2 doesn't work. And so chances are that we're running BGP between these ISPs and the HQ1 router, and we can validate that rather quickly. And maybe the issue has something to do with one of the BGP settings. Maybe it's an ACL of some kind, so we'll dig into that. Network documentation from the customer may not be correct, and this is the IP address that we're going to be using to troubleshoot. So let's go ahead. We'll tackle the branch issue first. So the first thing that we're going to do is let's confirm, and actually we're going to need to see the job aids here. Let's get these IPs. So the branch router IP is, so PC4 is 10.0, so PC4 out here is 10.0.30.7, and the branch router is 10.3.0.8. So I'm going to write those down real quick. So 10.3.0.8 is the branch 2 router, or the branch router. And 10.0.30.7 is PC4. So we'll be using those IPs as we make our way through this exercise. So we take a look at PC1 first here, and let's go ahead and see, can I ping out to PC4? 10.0.30.7. And let's see what we get. All right, so we're getting that network unreachable and the failure back. And so now let's see what happens if we were to trace out to 10.0.30.7. And we're going to do numeric, right? We don't want to sit around waiting for DNS resolution to take place. So we make it up to 10.1.0.7, which I believe, and we're going to confirm this here very quickly, is HQ2. So on HQ2, it looks like we're going to have this issue with the double typing. So here's what I'm going to do. Let me rather quickly here pull up the Manage Devices tab. And when you get those double characters like that, and this is something that happens often for some reason with the IOL in the TSHOOT labs, is to pull up the Manage Devices tab, and we are going to reload or power cycle HQ2. And so this is sort of one of the quicker ways to deal with it. You can see we're disconnected. If this doesn't work, what we need to do is we're going to have to jump out or exit out of the activity and then come right back into the activity. All right, so we're back on HQ2, and now it's even worse. We're getting 3 instances. So what I do here is I simply exit out. I bring us all the way back to this screen, and so we're at challenge 8, and then I'm going to dive back in. And this has sort of been a successful way to get back in here. All right, so now we are back in. Let's get HQ2 up, and hopefully, and there we go. Yeah, so very weird issue that comes up. So show IP interface brief. And we wanted to look at the trace. We were looking here when we said trace 10.0.30.7 numeric. And the PC doesn't like that. Show IP interface brief. Okay, so, and there we go. Okay, well, it took a while to get that address from exiting out and coming back in. So now let's go ahead and see, because the trace worked and actually it caught me there. Control-Shift-6. And let's do that numeric. And now we're getting to 10.0.10.1. And I'm thinking that we should be getting a little further than that. We should have gotten to 10.0. And it may be that things are booting up here. Let's check DSW and show IP interface brief. And then there's that 10. So we're making it to VLAN 10's SVI here on the distribution layer switch, but we should be getting a little further than that. We should be getting up to HQ2's 10.2.0.7. So let me try this again. And there we go. All right, well, actually, we get to 10.1.0.7, not 10.2.0.7. So we're getting to 10.1.0.7, which is not where we want to be. So from PC1, we've confirmed the issue, right? We clearly have an issue here. One of the interesting things about this activity is you'll see here, when I try to click on the branch or PC4, we don't have any access. Or I should say specifically, we don't have any console access. So what we could try to do is we could try to telnet to the branch router. So what happens if I try to telnet from here, from PC1? If I were to say telnet to 10.3.0.8, are we able to get to the branch router from PC1? Now remember this, you can see it's going to time out and it's not going to work, because this will come back to play an important part later in terms of recognizing what the issue truly is. So let's see, from HQ2, can I ping 10.3.0.8? Because again, it says here that Ethernet 01, which is the interface out which I am connected to the WAN, is up, but going through the WAN, do I have connectivity on the other side? So we do have connectivity on the other side, and we've been provided with a password to get onto that router over on the branch. So let's telnet over to 10.3.0.8, and the password is Cisco. All right, so now we're on the branch router. So let's put our password in here, and the branch has been cut off. So can I ping out to the internet, 209.165.200.129, and we're pretty certain that this is not going to work, simply because we can't go from the enterprise out to the branch. So we're not going to be able to go from the branch to the enterprise. If I were to trace that out, 209.165.200.129 numeric, what you're going to see is exactly that, is that we've got no connectivity. And let's go ahead and do Control-Shift-6, and it doesn't look like it's going to let me exit out here. And hopefully that's not the case, because we're going to actually be stuck. Try the Control-C. All right, so it looks like we may be stuck here. Let me see if I can go from the distribution layer switch, and I doubt it. Let's see if what we have in the routing table here. Do we have anything to 10.3.0? Actually, we do. So let's see if we can telnet from here to 10.3.0.8. Is that right? 10.3.0.8, that's correct. All right, so what is this telling us? So I try to telnet over to that branch router, but again, it's just kind of hanging. So chances are, while I may have a route to get there, there may not be return information that's needed. So if I come back to HQ2, and unfortunately I think we're going to have to wait for this. Yeah, so it looks like we're going to have to wait for this. So, excuse me. While we're waiting for that, let's go ahead and take a look at the diagram here, and we're going to get HQ1 up, and we're going to see, let's test from PC1, can we get to the internet? So we know that that was working, or should work, 165.200.129. All right, that works. If I trace out to 209.165.200.129 numeric, do we make it out? Seems at the third hop we've hit some issues here, but all right, and it appears that we can't. So we've got pinging capability, but we don't have the trace route capability out to, and the Control Shift 6 worked there. All right, so we can ping, but we can't trace route out. So, and it may be as a result that we may be blocking some things, because remember, these are ISPs. So let's take a look at HQ1. We want to see how this is configured. So show IP interface brief. And so we can see here's our inside interface, 10.107. And then here are the two. So this is interesting. So we're seeing this 10.107 here. So DSW1, yeah, exactly. Okay, is being given a default route, which is why our traffic was going to 10.107. So it was defaulting because it didn't have a more specific, longer match. All right, so we're back here on HQ1, and now we're kind of digging into this issue as to why when Ethernet 0.1 goes down, we don't have connectivity out to the ISP. So my guess is show run section router BGP is we are running BGP. So now we've got some distribute lists, right? Or I should say we're using distribute list for each of the neighbors. The name of the ACL is route out. And so we're probably limiting in the outbound direction, the advertisement. You could have used a route map and a prefix list, right? But they've chose to use a distribute list here. So my guess is that we are limiting the networks that we are advertising to the ISP. And so let's go ahead and say show Ip Bgp Summary. Okay, and this is clearly an issue here. So it looks as if the entry, or I should say the neighbor 209.165.201.5, Autonomous System 65222. So we are in the idle state. And it doesn't appear as if there's ever been an adjacency established here. So the first thing we want to do is validate that those are the correct IP. So can I ping 209.165.200.5? All right, and this is making me think, because that is up, that we have some sort of an ACL possibly in play here. So can I ping 201.5? All right, so ping is using ICMP echo requests and replies. Those aren't working. We had the same issue with ICMP. And so let's say show access. Or actually, let's do a look. Let's take a look at show run interface Ethernet 0.1. And there we go. We do have an access list in play here. And what about show run interface Ethernet 0.2? Okay, the same access list is applied in the inbound, or what would be the return path for this router. So let's go ahead and take a quick look here at show access list 100. Let's see what we've got here. Okay, so this ACL is literally allowing BGP, and that is it. All right, so this is allowing the BGP connectivity in the inbound direction. Everything's being allowed outbound, but from an inbound perspective, we're only allowing BGP. Now, quick review on BGP. How does it work? Well, remember, BGP is leveraging TCP port 179. So if I get the drawing tool out here, so we'll just simply say that this is the HQ router. This is our HQ1, and we're connected out to ISP1 and ISP2. Now remember that BGP, again, it's using TCP port 179. Or I should say that is where whoever is the initiator is going to be sending the BGP traffic. It's going to be going to port 179. And you can see that's why we have these multiple entries here. So, and to quickly talk about, if we look at 10 and 20 are matched up. And 10 and 20, we've got matches here, right? But no matches here. But that is okay. But we need both entries to make sure that we are taking into account how the TCP session would be initialized. And you can see here I'm going to be rolling over, whoops, I'm going to be rolling over to the RFC here in a second, specifically section 6.8 of RFC 4271 that talks about collisions and how these sessions are initiated. So back to why do we have two, and I'll draw a line along here, why do we have two BGP entries for each of the neighbors? And as I'm looking at this, I think I see what the problem is with the BGP ISP2 connection. That is our IP address, which is the opposite of what it should be. So these .5 entries here should be on this side, and the 6 entry should be over here. But again, let's talk about these two entries. So the first entry, what does it say? So permit the protocol TCP from 209.165.200.5 to 209.165.206. So this is us. This is the HQ router going to port 179. And that's what this equal BGP, that's our port number, right? Because again, BGP leverages port 179. So we're saying allow transmission control protocol traffic, TCP traffic, from the ISP to .6 to the HQ router destined to port 179, right? So traffic coming back to what would be the server. Remember, TCP, or I should say BGP, which leverages TCP, we're talking about a client-server relationship here. So then we've got the second entry which is required, which is allow TCP traffic from .5, so from the ISP coming or sourcing from port 179 coming to the router HQ1 on one of the ephemeral ports. So, and again, the ephemeral ports are greater than, any port greater than 1024, right? Those randomly high ports. So how would we see this? Well, let me clear the screen and let's take a little deeper dive here. So how do I know who the server is and who the client is in these scenarios? Is the ISP1 router or the ISP2 router, are those the servers and I'm the client? So one of the commands that you can use is show TCP Brief. And it's also a command that takes a couple seconds to run. So we'll give it some time here. And this is going to show us the TCP connections that we have established on the HQ1 router, specifically the functional connection between ISP1 and the HQ1 router. And there we go. Perfect, right? And so this is why we need to have the two entries. So here's the first entry, right? And it shows that this is established. Now this one here is in the closed state, so we're not going to worry about that one there. It's closed. But this is in the established state. And you can see here is your ephemeral randomly high port. So who is the server? The server is the one that is serving at port 179. So router, or I should say ISP1 is the server, right? And ISP2 is, I'm sorry, not ISP2. Then the HQ router is the client, right? Because the TCP server runs on port 179. And we're using that randomly high ephemeral, I hope I'm pronouncing that properly, the ephemeral TCP port, which indicates that we are the client going to the server port 179. So router 6 is the client. I should say router 6, I apologize. The HQ router is the client in this scenario, and the ISP is the server. And so remember, the reason that we need both of these entries is because we have to take into account what happens when we, the HQ router, right, would have port 179, or when we're allowing inbound from the ISP that is sourcing from port 179, which it is using port 179. So that's why we've got those two entries, and that's why those are required. And if we take a look at the fact that that is matching, it matches up with what we see here. Take a look at this. So the ISP router .5 sourcing from 179, right? It's right there, going to a randomly high ephemeral port on the HQ router. And that's exactly what we see with the show TCP brief output. So again, remember that there's a SYN ACK, and an ACK that takes place. In fact, if we took it one step further, and I've got this queued up here. So on real Cisco routers, if I were to go into global config and say router BGP 1, and then say neighbor, and my neighbor is 192.168. Again, this is out of the lab, but these are on routers that I've got kind of pre-configured here. Remote AS, I'm sorry, we're going to use .2 for router 2, and I say remote AS 2. We're not going to advertise any networks or anything. We're just going to stand up a BGP peering. Let me go ahead and kick off Wireshark. So we'll pull Wireshark up here, and let's start a capture. And we're going to say options. We're going to capture Ethernet 0, or interface 0. So we're going to capture that. Let's start the capture. And so we're going to see all kinds of stuff here, but we're going to be specifically looking. You can see we've got some DHCP and HSRP. We're not interested in that. What we are interested in is over here on router 2. When I come over here and I go into router BGP 1 and I say neighbor 192.168.1.1 remote AS 1. And so we should see that, and here we go, we've got some debugging going on. We've got the open messages going back and forth. But when we go back over to Wireshark, right, where we were capturing traffic, let's come back up here. And there's the ACK. I wonder if we see it a little higher above. And here is exactly what we're looking for. So take a look. The SYN, right? So here's the SYN. And then we should have, and it looks like it's quite a ways down here, our SYN ACK. Oh no, I'm sorry. This was when before I had hit it on router 2. Okay, here we go. Sorry about that. Thought it was going to be higher up there. So here is our SYN, right, from router 1 to router 2. I'm sending the synchronize, right, the synchronization packet in TCP. I've got my window size, my maximum segment size, and then we get our SYN ACK. So the SYN is going from router 1 to router 2 because we enabled the BGP process there first. Here, router 2, you can see, comes back with the SYN ACK, and this is after I enabled it on router 2. And then finally, from router 1 to router 2, we get the ACK. So again, BGP clearly leverages TCP. You can see that right here. And so if I were to bust this packet out, we look at TCP, the transmission control protocol here. Take a look at the destination port, right? So the destination port is 179. And the source port is the random high port of 39564. So the server in this instance is going to be router 2 because, again, our source is router 1, 1.1, going to the destination 1.2. but it's going to the destination of 1.2 and it's looking for port 179. All right, so that's just a quick look at setting up a BGP adjacency and the fact that it is using TCP and it's using port 179. So here's my server running on 179, and here are the clients, or here's the client coming through on a random high ephemeral port. So now when we look at this, right, and that's an explanation of what these and why we need both of the entries, right, to account for both directions. Or I should say, not so much both directions, but both routers being the client or the server. But what we see here is we've got this in the outbound, or what would be considered in the outbound direction. However, the ACL is being applied inbound, which means inbound traffic is going to be coming from the ISP routers. So these entries here, you can clearly see that these are backwards, which is why we've got this sitting in the active state, right? So let's clear the screen here and let's sort this out. And again, very simple to change. And in fact, when you look at this, it just dawned on me, this may be why we're not seeing any of the ICMP traffic come back. So I'm going to add another entry, and I'm not sure if they're requiring that or not, but I'm going to add it in there anyway. All right, so let's spice things up a bit here. Let's get into IP access list extended 100. We're going to say no 30 and no 40. And now I'm going to add my entries back in. And again, my entries, with the exception of the third octet, are going to be identical to these first two entries, access control entries 10 and 20. So let's mimic those. So we're going to say permit TCP host 201.5 to host 201.165.200.201. I'm going to mess that up sooner or later here. 201 equal to BGP, right? And so what is that entry? Again, why do we have the two entries? So this first entry is saying if it's coming into the HQ router .6 at port 179. And so that's what this is saying here. And this would be saying that .6 is the server, and it's running on port 179 for BGP. So let's add this in and let's see what happens. So we hit enter, and do we get any matches? Do we get the adjacency coming up? We don't. Now remember, we've got a second entry. Oh wait, there it is. All right, good. I was going to say we have a second entry that we could put in, but the adjacency comes up. So if I were to say do show TCP brief, and hopefully we get this back a little quicker than we did earlier. And I'll also show you another way to take a look at this as well, because you could take a look at the neighbor statement and then go down and look at the ports that are listed, which probably would be a little quicker than this. Okay, and so good news here, right? So take a look. Remember, before I even hit enter here, we were talking about that entry right there. And what does that entry really mean? It means that the HQ router is the server, that this is inbound traffic coming from the ISP going to the HQ router destined to port 179. And believe me, these entries are always confusing when you first look at them. You know, because you've got two of them there and you're trying to figure out the directionality. So take a look, right? It's kind of backwards, right? Because we allowed this inbound traffic to, and here we are right here, to come into the HQ router from the ISP router who's using a random high port. And take a look at that. That is our server, 201.6, which is HQ1's interface, right? That's HQ1. That is the server. And so that's what that first line means, is that 5 is initiating a connection to the HQ router on TCP port 179. All right, so let's add our second entry in here, and then we'll take a look at the neighbor statement. So the second entry is going to be, what are we doing here? Permit, oops, sorry, didn't mean to hit that. Let's see, so we want permit TCP host 209.165.201.5 equal to BGP. So this accounts for the case where it's coming in from port 179, not going to port, or sourcing from port 179, not going to port 179 like we are. Where did that entry go? Where is that TCP brief entry we just had? Oh, here, sorry, it was right above me. This is where we're going to 179. This is if we're sourcing from port 179, going to host 209.165.201.6. And I said I was going to add in, I'll put it in here, we'll say it's just going to be access control entry 900. I want to allow, let's permit ICMP any. So I want to allow ICMP to come back through, just in case. Okay, so we've got that taken care of. Do show access list 100. All right, and so that's what we've got now. And take a look at that, right? It worked out well, where we got an opportunity to see the matches on ACE 20, right? Access control entry 20 and access control entry 30, even though they were opposite. Now, I showed you the do show TCP brief. Another way that we can look at this, and let's get out here. So we'll say show BGP, or if we were to use the show BGP, IPv4, unicast. Is it all, or is it just right into neighbors? Neighbors, there we go. Into neighbors. Now, there will be, and I should probably trim this down. And let's do that. Let's say include port. All right, perfect. So we were able to trim things down based off of the port, right? And we basically did the output. But you can see here, local host, foreign host, local host, foreign host. So the local port is 179. And again, this was way quicker than the show TCP brief. And then we have the foreign, or the ephemeral, the random high port. Same thing here. Right? And this tells me right away that when I see foreign port 179, I know that this is the server in the client-server relationship, because the client is sending traffic to 179, that TCP traffic, from a random high port. So here we can say 200.5. We know that to be the ISP1 connection. So ISP1 in this case is the server and the client-server relationship with BGP. And then down here, this was the connection we were tinkering with, and take a look at what we've got. We ended up with something opposite, right? Where we had already put this access control entry first, where we said that the HQ router would be the server and would allow in connections to port 179 running locally on the HQ router, and it came in from a random high ephemeral port here on the ISP2 connection. So again, two different ways that we can take a look at things, and we saw, right, remember we said client server, and so let's take a little deeper dive here. How could you control who the client and who the server are? Well, you could control it with the ACL to an extent, but if you don't control the routers on both ends, then you may run into an issue, right? And that kind of pulls into play here when we talk about the collision detection. And I'm looking at RFC 4271, which is the definitive source for the BGP standard, right? And this talks about what happens when the conversation is trying to be established and maybe there is a collision where both speakers are trying to go at the same time. So in the case where you end up with, you know, two quote-unquote, we'll say BGP servers, or the routers that are trying to act as servers, typically you have to define in the BGP config which has the higher, what the IP addresses are, so the router will know who would be the server and who would be the client, or who would initiate the communication, but this can be controlled with a command called TCP, well, I shouldn't say TCP, transport connection mode, right? So let's take a look at what happens with transport connection mode. So we'll go back over here to the lab. So let's say that I'm the HQ router, right? And for the sake of argument, and actually this is probably going to be better demonstrated over here, and let's get this debugging turned off here. Let's say do you all. So what I'm going to do is we're going to come into, we're just going to go to router 1. Do you all. All right. So we're in router 1 here, and what are we getting here? It looks like, and did we set something up incorrectly? Do show run section BGP remote AS1 of, oh, I certainly did. Yeah, so we had the SYN-SYNAC ACK, but take a look at that. I actually used the wrong BGP, so let's exit out of here, say no router BGP 1, and we should be router BGP 2. And I'll just grab these two statements, or actually just a single statement here. We'll copy and paste that, and we're going to bring BGP back up. Okay, so the BGP adjacency is going to come back up. There we go. And it was bouncing because I didn't even see that I'd made that mistake, but we had the wrong autonomous system number defined. All right, so now we don't have the wrong autonomous system number defined. We're good to go here. So what I could do is I could say neighbor 192.168.1.1, and this is where I would put in the transport, the transport connection mode. And so these are the two options we have, active and passive. So since I control both of these routers, if I wanted to dictate whether this router would actively try to initiate the TCP session, I would put active. If I wanted it to wait, and you could think of it like this, a good analogy are the ether channel protocols, PAGP and LACP, right? With LACP, we have active passive. With PAGP, we have desirable and auto. And it's kind of the same thing here with the BGP connection. Who do I want to initiate the BGP session? Because if I set this up, right, then I could do an ACL with a single entry, because then I have 100% control and I know which router is going to be initiating the connection. I don't need to take into consideration that it could come from either direction, right? Because I'm dealing with an ISP at my internet edge. So let's go ahead and we'll say passive. And so, whoops, and oh, got an extra period in there. I was like, that should have taken. So there we go. So what I've just said there is that router 1 in this scenario is going to wait for router 2 to initiate the BGP TCP three-way handshake. And that we should not see router 1 sending SYN packets, that we should see router 1 waiting. And so, I'm sorry, I'm on router, yeah, or I'm passive to router 1. Right, so I think I got this backwards. So let me correct myself. I thought it was on router 1, but I'm on router 2, and I basically said that router 2 will be waiting for router 1 to initiate the TCP session, that I am going to be passive as router 2. I'm sitting here waiting for router 1. So let's do this. I'm going to set passive on both sides here. So let's go ahead and say neighbor 192.168.1.2 transport mode or connection mode is going to be passive. So let's go ahead and capture with Wireshark here. Let me kick this capture off again, continue without saving. We're going to come back here and say do clear IP BGP star. Let's see what happens. Do either of these send out SYN packets? All right. I don't see any yet. If I come back over here, do we see anything saying that the session has come up? Do show IP BGP summary? No, we're in the idle state, right? Because again, I've configured both routers to wait for somebody else, in this case, the other neighbor, to initiate this BGP connection, right? To start this TCP three-way handshake, they're both sitting in the passive state, so we see nothing, right? We see nothing here. So let's go ahead and change. We'll change router 1. We'll pull back this statement here. And we'll say no neighbor 192.168 transport connection mode passive. I'll take that off, and I'll see if I can get it in here. We'll say 192.168. So for router 1's view, transport connect. Oh, and it already beat me there. We're going to say connection mode active, so that it would be. Sorry about that. Connection mode active, so that it will take the initiative. Router 1 will take the initiative to initiate that communication, which we should see over here if I were to stop this. And we scroll back just a little bit, and there it is. So there's my SYN from router 1 to router 2, the SYN ACK from 2 back to 1, because remember, router 2 has been configured to be passive at this point, right? It's going to be passive and wait. And so that's how you can actually control which router is going to initiate the session. Whoops, and I want that back. Okay. So here we go. So we're back on the HQ router. We've solved our issue here. So let's say show Ip Bgp Summary. Again, wanted to go a little deeper and to explain what we're seeing, not just simply type in the commands and say, hey, look, it's fixed. Okay, so there we go. So we've got our connections up. So if I were to go into interface, let's get into global config, interface Ethernet 01, and shut it down. Remember, the claim was that we lost connectivity. So now, can I ping out to 209.165.200.129? All right, that's fantastic. Now, what if I trace out there? 209.165.200.129 numeric. And take a look at that. Absolutely fantastic. And we can tell from the IP address right there that we are going out to ISP2, that was our hop. Okay, so that has resolved the BGP issue that we were having. Now let's go back to HQ2 and the never-ending traceroute saga. All right, so we're going to transition, shifting gears here. Remember, the problem here is that we can't get console access to branch, the branch in HQ, or I'm sorry, the branch or the PC4 in the branch. So what we did notice was that we have narrowed it down, that it's something taking place here between the HQ and the branch router. So on HQ2, if I was to say show IP route, do I have any information to get me to the 10.0.30? So I've got 10.0.10 and 10.0.20, but I don't have anything for the 10.0.30, and I'm running EIGRP here. So it makes sense that when we're tracing from the PCs or from the other routers that we don't know where to go, well, actually, I shouldn't say that. We do know where to go. Where are we going? We're taking this default route. So back to PC1, if I was to say trace to 10.0.30.7 numeric, excuse me, it takes me up to 10.107. Now remember, 10.107, that's the HQ1 router. That interface resides here, Ethernet 00. Remember that? Do show IP interface brief, and there it is. So we get up to this router, and HQ1, do show IP route, has a static to null 0, right? And again, I can explain and I've got a separate video. In fact, the next video I'm going to talk about this null 0 question came up Thursday night. Evan asked it, and it was a great question. And so I want to dedicate some time to that to make sure that the understanding on this is clear. So we don't have a longer, more specific match, do we? So then we're going to take that as our default route, but we don't have a longer, more specific match, which means it drops the traffic, right? So we're going to be dropping that traffic because we basically don't know where to send this traffic. Excuse me. So that's why we end up with these characters down here, that we get to that next hop because the DS, the distribution layer switch, sends me there with a default route. But then when I get here, there's a default route, but there's no longer more specific match. So the traffic is going to be shoved out the default route, which is null 0. And again, I'll explain that, which means if we don't know where to send it, we send it to the default, and the default is null 0, which null 0 is your bit bucket. It just drops the traffic. And so that's why we see this output here. So we know we don't have the routing information. Let's take a look at show run. How about section router EIGRP? Okay, good. We're not using named mode here. We're using classic 32-bit mode. And we've got our network entry statements there. What about a show IP EIGRP neighbors or interfaces? So I've got the neighbor relationship, and you can see that it's with 10208. Well, that's the distribution layer switch. What about a show IP EIGRP interfaces? So I do have EIGRP running on the interface facing that branch router, but how many peers do I have out that interface? None. So now we've focused it down to it's something preventing EIGRP. So we've got some kind of an issue where we don't have a peering with EIGRP. So we're not going to trace route this time, that's for certain, but let's telnet over to 10.3.0.8, which is the branch router. We're going to put that password in here. Whoops, C1SC0. All right, we're on the branch router, and let's get the privilege exec password in there. And so let's go ahead and say show IP EIGRP neighbors. So what does this see? So no neighbors. The AS number is the same, right? Because that's the first thing we want to check. Remember, the AS numbers need to match. So they do. So this tells me that it's something else. So what about a show run? How about a show run? Or how about a show IP EIGRP interfaces? So it is set up on the Ethernet 00. So show run section router EIGRP. And let's see, we've got the entry for the /24, and then here is our problem. Upon close examination, take a look at what we've got here. We have a network statement that is saying on the interface that has the exact IP 10.3.0.0, and I say it's exact because our wildcard mask is the quad 0. Now, that is not representing the default route. Remember, this is a wildcard mask, so we're talking about bit matching here. And when we have the quad 0 wildcard mask, what we're saying is that the network statement, the IP address, must match exactly. Well, what is show IP interface brief? What is the IP on the interface facing the HQ2 router? It's 10.3.0.8. It's not 10.3.0.0, right? It's 10.3.0.8. So we've identified the problem. Now we're going to resolve the issue by changing this statement. And there's a couple ways we could change the statement. The first way is I could say network 10.3.0.8 and then leave the quad zeros. And that's going to work. That would be fine. So let's do that. We'll take a look at both ways here. So we'll say router EIGRP is at 100. And I'm going to say no network 10.3.0.0.0.0.0. Right, so we'll remove the bogus network statement. So let's put in the first approach we could take. 10.3.0.8 with the quad zeros. And what we should see is our adjacency comes up. Because again, remember, the quad 0 wildcard mask dictates that the IP match exactly, right? And so we're good with this. This works. No problems here. So real quickly, what would be the alternate solution? Exactly. Is that we specify the 10.3.0 network, but use a wildcard mask that's appropriate, which is, if I were to say do show run interface Ethernet, should be a 24 is my guess. Yeah, use a wildcard mask that correctly represents the subnet mask of 24 bits. So we would say 0.0.0, oops, sorry, 0.0.0, 0.0.0.255. And so that would match. And remember, when we looked at the statements on router HQ2, how was that set up here? And I know we looked at that. I thought we looked at that. Let me continue to cruise back up here. It was further up, I think. No. So the statements on HQ2, let me slide back over. The statements on HQ2 actually use a /24 subnet mask. So let's go ahead and remove the statement we just added. And we're going to match the way we have things set up. Network 10.3.0.0. So what we're saying here is that the network was correct, that the wildcard mask was what really needed to be fixed. But again, I want to show you more than one way to do it, because it's more important to understand the different approaches than for me to just simply say, oh, just type this command in, that's the answer, right? Remember, there's always going to be, 99% of the time, I should say, there'll always be more than one way to solve the issue. So now we put that statement in, and again, it works, right? Because we're starting the EIGRP process on the correct interface. There were just two ways that we could do it, right? So if I were to say do show run section router EIGRP, there we go. So from the branch router, what if I ping out? Do I have connectivity to 200.129? We do. What if I were to say trace to 209.165.200.129 numeric? Take a look at that, and we know that we are going out ISP2. So real quickly, let's deal with that. Let's say no shut. And let's see what happens. We should have a BGP peering that comes back up. After the interface comes up, we should see, there we go. ISP1's connection is now live. So if I come back over to that branch router and let's trace now. All right, looks like we're going to wait for BGP might have to converge here before we get this to switch. We should see for hops 4 and 5, or specifically for 4, we should see 209.165.200.5. And in fact, let me go ahead, I'll force the issue here. Let's say do clear IP BGP star. So we'll reset both BGP connections. All right, so we're going to have to wait for things here a second, but that's okay. So again, we're getting to the HQ router, but we're waiting for BGP to settle down. But what we should see is for hop 4, we should be going out 200.5, which is ISP1, because that is our primary exit point. All right. Boy, BGP is definitely not the quickest to converge. And I'm hoping that this comes back up in the next couple seconds. And if it doesn't, I'll just simply pause and wait for it to come back. All right, so we do have connectivity from the branch up to the HQ router, so that's been resolved. And we should be going to 200.5 here any second now. It skipped the 200. It skipped the 205 because I'm wondering if the echo replies. Yeah, and it might be something to do with the ACL, and this will be the last thing we look at here. Do show run interface Ethernet 01, and that should not be a problem. Although, yeah, we should have seen that coming back in on do show run interface Ethernet 02 is the same. Interesting. All right, so we are able to get out, but I'm not going to spin our wheels here trying to sort out why we're not seeing that hop. So again, that resolved the issue. We're now going back out that primary path. All right, well, this is going to wrap up challenge number 8. Again, we did a deep dive on BGP, did a little review as to how BGP functions. TCP port 179, we've got an ACK, SYN-ACK, ACK, or I should say SYN, SYN-ACK, ACK. And then we looked at the EIGRP issue here. All right, guys, enjoy